Let's make things just a tad bit hairier now. And we want to verify a trigonometric identity. And what that means is you want to make the left side equal to the right side. Or you go the other way around. You want to make the right side equal to the left. Okay? And as a general rule, you always want to deal with the side that has more information, more trig functions, because that means you can do more manipulation. Trying to convert cosecant into the left side is going to be quite difficult. So that's why we're going to start with the left side, okay? And when we verify identities, you only work with one side the entire time until you get the equivalent of the opposite side. So once I start working with the left side, I'm just going to keep going and going and going. And my goal is at the very end is to get this entire side to be cosecant of theta. All right? So that's what we want to do here. And let's get cracking here. All right, so sine of theta all over 1 plus cosine of theta plus cosine of theta over sine of theta. Well, we have two fractions, right? Can we go ahead and add two fractions together by getting a common denominator? Okay. And what the heck? Sorry there. That's a little mix-up there. Let's go back. Okay, there we go. So let's go ahead and multiply both sides. That's going to give them a common denominator. For example, I'm going to multiply this side by sine of theta. And then I'm going to multiply this side by this denominator by 1 plus cosine of theta. And as you can see here, this denominator is sine times 1 plus cosine theta. And this denominator is sine times 1 plus cosine theta. So see how they both have the same denominator? That's the point of adding fractions, is to first get a common denominator. So sine of theta times sine of theta is sine squared of theta plus cosine of cosine times 1 times cosine times cosine. So I'm going to do this a little backwards. Cosine times cosine is cosine squared theta, and then cosine times 1 is just cosine of theta. All right, so that's what all of the numerators give us if I add these two together. And they all have a common denominator of sine theta times 1 plus cosine of theta. Now, I chose not to distribute the sine yet, and you're going to find out why here in just a minute, why I didn't do that. And so watch this. We know that sine of theta squared and cosine of theta squared is 1. That's one of our Pythagorean identities. So I'm going to replace this whole guy with 1. Okay, so this whole thing is 1. So 1 plus cosine of theta, see, a little tricky, all over sine of theta, all over 1 plus cosine of theta. So look how rad this is. We have a 1 plus cosine of theta in the numerator, a 1 plus cosine of theta in the denominator. Bust out your math sword, wata, and we get 1 over sine of theta, and lo and behold, 1 over sine of theta is cosecant. Cosecant. If I can write cosecant correctly, that would be nice. Let me try that again. So try it again. Now we have cosecant theta, and as you can see, this side is equal to that side. So now we just verified that this whole tamale is equal to cosecant of theta.